modes, equipment, and industrial application. Before moving to the lesson, I want to share with you our table of content, which we will talk about them. We'll start with heat transfer modes, which you know there are conduction, convection, and radiation. Also, heat transfer equipment like heat exchanger, shell and tube exchanger, double piped exchanger plate, then air coolers, reboiler, etc. Then we will talk about fouling, which is one of the biggest operational headache in industry, and then we will move to our case study and its solution. Okay, before moving into the type of modes, I want to make sure that we are all aligned with what heat actually is. Heat is a form of energy that can be transported from one system to another with purely because of temperature difference. It means that temperature difference here is driving force. No temperature difference, meaning that no driving force. Simple as that. Also, it's not just about like how much heat you transfer. It's about how quickly, how long you transfer this heat. Because you are working in industry, and like here, our aim is not just naturally like use heat transfer modes, but at the same time to use how duration time at the same time. Think about a hot coffee pot on a table. You see the temperature here is 70 degree, but the ambient temperature is 20 degree. You see there is a difference. Driving force here is temperature. Eventually, we know that it will reach to like room temperature. We know that. But if you're designing a heat exchanger, you need to know that why will it cool down? You are not asking like, will it cool down? You will be asked that how long it will take and how much equipment do I need to make it happen fast enough for your processes. And we will deal with it. And now I'm moving to mode of heat transfer. The first one is conduction. I'm pretty sure that you heard about it. Like think it like you have heat moving through a material, but material itself doesn't move, as you know. In solid, for example, the atoms are locked here in lattice, but they can't go anywhere, but they vibrate and pass energy from one to another. This is applicable for solids, but in gases and liquid, it's slightly different because here molecules collide and diffuse and pass energy from one to another. So do you have any example for conduction? You can raise your hand or you can type your chat. Or I will ask randomly. Okay, currently I can't see. Maybe you raised. Okay, Elvin.
Elvin raised his hand. Yes, sorry.
For example, when we touch something hot, we feel its hotness via the conduction.
Sorry, I couldn't get your point.
For example, when we touch something hot,
Yes.
For example, hot spoon, we feel its hotness. It's happened via the conduction mechanism.
Yes, exactly. This classic example from like basic life. Thank you, Elvin.
In an industry, when outer because heat from the outer side of tube heats up the inside side of tube.
Right? Yes. For example, in shell and tube exchanger. Yes. Thank you for your both example. As a classic example, I would give like a cold canned drink, which you know, like in a warm room. Eventually, like it warms up, but that heat travels through the aluminum can can be by conduction. Like this is the example for conduction, but here the aluminum wall is like. This is aluminum wall. This is a medium. Like the energy passes through it, but aluminum can't go anywhere. This is stable, but heat transferred through from one medium to another. This is the classic example for conduction. Coming to industrial application, I would give you 3 basic examples. For example, in pipeline and vessel, in furnace, in heat exchanger, we will talk about them. all of them. But firstly, I want to talk about a little bit pipeline and vessel insulation. So when you have when you deal with crude oil pipeline, which runs at high temperature, like temperature is too high, and you wrap it up, like this is your pipeline, and let's say you wrap it up with wool insulation. You know, wool insulation. This wool insulation, we wrap it with wool insulation because the reason is simple here. This mineral wool insulation has very low thermal conductivity, meaning that it's very pure conductor. Okay, like it limits your leakage to atmosphere, your temperature leakage to atmosphere. If we let heat escape freely, like your crude oil will, like the temperature of crude oil will cool down, and viscosity of the fluid will increase, and you can get the at the end wax deposition. This is the one of the serious operational problem in fluid, and we want to avoid from wax deposition. This is one of the industrial application where we use the conduction. But second is convection. This is the second mode of the heat transfer. Here, fluid motion gets involved. In previous one, we said that just energy passed from one molecule to another, but here fluid motion gets involved. Convection is a transfer of heat between a solid surface, as you know, and this moving fluid. It can be either liquid or it can be either gas. For example, I would give example from you blow on hot food in order to cool it faster, and just leaving it in still rather than just leaving it in still air. Like you know that if you blow it, it will cool down faster because you are forcing convective heat transfer by moving the fluid here. And in the home, you can see another applications. But coming to industry, this is one of the most dominant mode in heat exchangers, you will work with day to day. For example, shell and tube exchanger, air cooler, distillation column, reboilers. I will talk shell and tube exchanger. You can search about them, and we will talk actually about them later on. In shell and tube exchanger, I will show the picture to you. Yes. We have shell side and tube side. Yes, we will talk about them. In both sides, like you see here, they are tubes. Like we have here tubes, and you can see from there. And outer side of these tubes called shell side. In both sides are forced by convection. Like the fluid on the tube side is pumped through the tube, and the shell side is pumped across the tube bundle. Here also we have tube baffles. I mean, these are called baffles. This baffle design inside the shell are specifically designed for increasing the turbulence and also increasing the convective heat transfer coefficient. It means that more turbulence means better heat transfer for your equipment, for your industry. Okay, coming to radiation. Radiation is energy emitted by matter in the form of electromagnetic waves or photons due to change in the electronic configuration of atoms and molecules. Here we use actually it travels through a vacuum perfectly well. It means that, for example, that's how the sun energy reaches to us. This is one of example from our daily life. Here the governing equation is Stefan Boltzmann equation, which we will use in calculation in finding the amount of radiation emitted. Here you see that heat emission is proportional to the forced power of absolute temperature. You see that the temperature to the forced power relationship is critical. Why? It means that your radiation becomes enormously significant at high temperature. For example, if your temperature you double your temperature, increase 2 times, it means that your radiation increased 16 times. 2 times and 16 times. Sorry for my handwriting. This is precisely why radiation dominates at high temperature rather than small temperature we just neglected. And in black body, it's a theoretical perfect emitter and absorber. like it represents the upper radiation, because here we have emissivity factor. This emissivity can range from 0 to 1. When it's 1, it's like perfect absorber, and it's called black body. Its maximum rate. Coming to its industrial application, like it's further applicable and widely applicable in fired heater or furnaces, we can call, because you have burner flames at 1200 degree or 1600 degree Celsius. At those temperature, radiation absolutely dominates, because as we said that as temperature increases, the amount of radiation also increases. And the flames here, and also we have in furnaces hot refractory walls radiating like enormous energy directly to your process tubes. Also, like convection, in fired heater we have 3 types of mode. Also convection, we have conduction, and also radiation. So now we will, if you have question, you can raise anytime. If you don't have question, we will move to heat transfer equipment. Like you can see the name of them here, which we will talk about each of them mostly, but they are different. They are like differing from each other based on their operational problem, their troubleshooting, their advantages, their disadvantages, like in industry, their applicability. So like this is all critical decision, like this all affects a critical engineering decision. So let me walk through the main types firstly. But before moving it, I will talk about heat exchanger selection. There are 6 driving selection processes, characters for selecting right heat exchanger. First is heat transfer rate. It shows how much duty do you need to achieve. Like it also sets the size of equipment. Why size is important for us? Because like it is required. For example, if we are working in offshore, as you know, there is a limited space availability. There is limited space. That's why choosing like appropriate heat exchanger based on its heat transfer rate will affect at the end our choice and also our process. Of course, cost. We have both capital cost and operational cost, capex and opex. We will need to look this parameter also, and pumping power, because some exchanger configuration create literally significant pressure drop. We will talk about the types, and I will tell you which one really has significant pressure drop. It means that if you have significant pressure drop, it also means that you will need higher pumping costs. At the end, if it will also affect the second point. And also size and weight, as I already mentioned it, type and material, they are also like affecting the choice of heat exchanger, because if you design like heat exchanger in your university year, the fluid here like can be corrosive. It can be like its temperature, its pressure, and falling tendency. All of them drive what type of heat exchanger and what type of material you need to choose while designing your heat exchanger. So let's dive into the types of heat exchanger. We have first the simplest one is double pipe heat exchanger. Like it's literally one pipe inside another. Your hot fluid enters from one side and moves, as you see, like it moves through one side to another. Like it leaves the system as warm or cold fluid. For example, it enters at 100 degree, it leaves at 80 degree. But in like in outer side, we have additional tube, and it like your cold fluid enters from there and leaves from here as again hot or like hot or warm fluid. Here we have 2 type of arrangement. One is counter flow, another is parallel flow. Like you see, like of course counter flow, the fluid direction you see here, like cold enters, cold out, but hot enters and hot out. The direction is vice versa. It means that like here direction is opposite. This maintains actually more uniform temperature difference, and more temperature difference means that more heat transfer within heat exchanger, and also at the end with like more heat transfer, meaning high efficiency, better efficiency than parallel flow. But in parallel flow, you see cold enters and cold out, hot enters and hot out. They are all in same direction, so fluid moves same direction. Also from this graph, you can see that like in parallel flow, at the beginning, the temperature difference is high, but at the end, like they are almost like equal or same. But in counterflow, you see like your hot fluid comes from there to here, but your hot fluid comes from there to there. Like temperature difference, temperature gradient is higher in counterflow. And coming to advantage and disadvantage, like the advantage of double pipe heat exchanger, like they are simple, you know. It means that as it's simple, lower capital cost and easy to maintain, also can handle with high pressure, also high temperature, and they are small compared to shell and tube. It means that like there is no need so much space, and it's very popular in industry and standardized. It means that maintenance and repair process is easy. Like the parts of it can be found easily, rather than like searching more a lot time and using your time. And as mentioned, like the high pressure and temperature, for it's applicable when high pressure, you have high pressure and temperature. Like, but also at the same time, they have some disadvantages because there is a limited area for heat transfer, and it decrease its efficiency. Like if you have large duty, yes, if you have large duty, you can't use it because it's more prone to leaking over time. And also the rule of some industry is that use double pipe for when you have low duty, but where simplicity and pressure matters. But like, for example, if the space is limited, you can use uh, double pipe heat exchanger if you have high pressure, high temperature, but the heat transfer area is limited, and also a leaking can happen in double pipe heat exchanger. But the most known one is shell and tube heat exchanger. I'm pretty sure that you heard about shell and tube heat exchanger already. And you can see here, like just pictures. I will talk about them. This is the picture from industry. You see here we have hundreds of tubes. These like circles show that how many tubes you have, and tubes you see. And here we can see the shell side. This accounts just 85% of whole exchangers in refining, in chemical, in petrochemical industry. So when someone says the heat exchanger on the plant, this is almost like means that shell and tube exchanger. The idea is pretty straightforward. Instead of one tube, instead of one bigger tube, you have thousands of, you see here, smaller, like thinner tubes, all sitting in a large cylindrical shape. So one fluid through the tubes, like these tubes, for example, from there through these tubes and go out. This is fluid in, this is out, and another comes from the shell side from there and leaves from there. So, okay, the baffles here, as I mentioned, like force the shell side fluid to cross the tube bundle, rather than like creating a straight fluid, because if the fluid is straight, it means that there will be less heat transfer. Your buffer helps to increase efficiency and heat transfer in heat exchanger. So in industry, why it dominates? Because like it handles like in almost any duty with any temperature, any pressure, and it can be built in many materials depending on your process fluid. If it's corrosive, it's erosive. Depending on this, you can choose your shell and tube exchanger with different materials, of course, and it can have many suppliers as it's well known, as it dominates 85% of industry. Also, repair can be done easily. Also, like the maintenance, repairness process is and cleanness of these tubes is difficult, but most like vendors choose shell and tube exchanger. And I will put here one link. It's about like standards. We have different types of standards. One of them is TEMA. You heard about it, I assume, or API. Petroleum Industries 660. Like this is like design codes widely applicable in heat exchangers. Mostly you will hear about TEMA if you work in chemical engineering. Like here, TEMA shows data sheet about configuration of your heat exchanger. You can write different type of configuration based on like design. For example, like it also like shows you your front head of tube, shell and tube exchanger shell type, rear head, like all of them shows one parameter, and at the end you just got your designed parameter for your heat exchanger. And another type of heat exchanger is plate heat exchanger. It's a little bit different from previous ones because instead of tube, like in previous we had tube, but here we use plates. As you can see, a lot of plates, thin plates we have here. Like these thin metal plates in a frame that do two things. First, increase surface area, and also create turbulence in the fluid. Like if you increase your turbulence, it means that your you have also high transfer coefficient in very compact package. But also they have, like you can see here, advantage. Okay, it's again low cost, about its reliability, its like capacity, because like it looks really useful from here, but like if we compare it with shell and tube exchanger, it's really compact. But coming to disadvantages, they have really limitation in industry. If you have like not pure material, any suspended solid in your fluid can block the channels, and of course at the end decrease your transfer area, transfer coefficient. So it means that you need a very clean stream if you are using plate exchanger. Also, high temperature, high operating pressure also limits your application. It's out of this plate exchanger scope. But where they shine, if you ask where I can use plate exchanger, I would say if you have clean stream, as I mentioned, if your utility services clean, or your space is tight, or your pressure are moderate, or your temperature in range, you can use it. Like for example, in food and pharmaceutical industry, mainly plate exchanger is used, but in oil and gas industry, mainly we will deal with a high temperature. That's why we prefer shell and heat exchanger, shell and tube exchanger. But besides like these types of heat exchanger, we have air cooler and reboiler. Here you can see the video, like link for air cooler. You can watch it later on because we have limited time. I will talk myself about air cooler. Like everyone on the plant calls it as fin fan. I also was in different internships. They called it not air cooler, mostly fin fan. Like it's used when you want to reject heat to atmosphere, like without needing any cooling water. Like if you don't have any cooling water, or like you don't want to lose your cooling water for these purposes, you can use ambient air. Like here in like we have spinning fan, and processed fluid goes inside tubes, but these fans force ambient air across the outside. Like this both combination help use this like air to cool your process fluid, because your process fluid is too high, but your ambient temperature is almost 20-40 degree, between 20-40 degree, and it will somehow decrease your temperature of the fluid. It's governed by like API 661. You can, if you have time, you can search detail about this API. Also, but here critical operational constraint. Also, we use in distillation column, in gas compressor inlet outlet, but limited operational constraint we have, because your minimum achievable temperature is always limited. Because like you work with ambient temperature in summer, for example, if temperature is 40 degree, your margin is drastically reduced compared to winter. And we will talk about it later on in our case study, and I will like look your approach about this ambient temperature. Okay, coming to reboiler. Here, reboilers sit at the bottom of distillation column. If we have distillation column, you know, at the top we have condenser, but at the end we have reboiler, where some of the like vaporized fluid goes again to the column, but some of them is removed from the system. Like basically their job particularly vaporize the bottom liquid to generate the vapor. And why we do it? Because increase the efficiency of separation. As you know. We have different types of reboiler based on their orientation. It can be vertical, as you can see from this picture, or it can be horizontal. Again, depending on different parameters. For example, if a specific application, again, available space, also heat transfer level, etc. Also, all of them affect your choice of reboiler and reboiler design. But coming to types of circulation, as you know, reboilers can be forced or natural type of reboiler. For example, forced circulation reboiler, kettle reboiler, thermospin reboiler. Thermospin one is the most common, because here natural circulation driven by by density difference. It means that your boiling fluid rises, but cooler fluid falls based on difference on density. Like here we have continuous loop without no pump, as fluid like the hot fluid rises to the top, but cold liquid is supplied always from the bottom. There is some loop in circulation. But this is compact. For example, thermospin reboiler is compact and efficient, but you have to stay within the vaporization limit, as it's occurred by natural circulation. But in forced circulation, for example, here you add some pump here, and it's used for if you have viscous fluid, if you have heavily falling fluid that can cause this issue, then natural circulation is not enough. That's why we need forced circulation reboiler. So again, here we have link. If you click this word, you will be directed to more about reboilers. Before moving here, I want just ask a question about what is falling. Who knows about falling? Or let me ask randomly from the names. I just took the name. Just a minute. Let me ask from Isa. Isa, what's falling issue in heat exchanger?
I think it is about the materials. problems, materials corrosion, maybe.
Okay. We will see if you are correct or not. Let me ask another people. Sabina, what is falling?
Fouling is about the like unwanted accumulation inside the shell and tube.
Okay. Okay, yes, exactly. Thank you, guys. Falling, first of all, is number one operational problem in heat exchanger. This is the position of unwanted materials, which can be scale, which can be suspended solid, which can be soluble salt, algae, some microbiological agents that can be accumulated, as Sabina said, and cause like decrease of heat transfer. These deposits actually are pure thermal conductors. They add some resistance between your two fluids, and your exchanger performance drop down. Here also heat duty like drops. As heat duty drops, it means that like your pressure drop because your channel, like the deposit narrow your flow channel, and of course it will cause pressure drop increase. What like it causes? First of all, why it happens? If you are asking, we use sometimes we use hard water. Hard water. It means that in water you have some minerals. For example, calcium carbonate. This water like isn't purified. That's why after some time, the building of this calcium carbonate can cause scale issue in your heat exchanger. And of course, like your tubes, as you can see from here, some tubes are not working. That's why the efficiency will automatically decrease. For example, if you use some like crude oil, for example, like unpurified or unclean like crude oil, it will cause also issues because biological fouling can happen. Here can be algae, can be biofilm. It can mostly occur in cooling towers because we use constantly water here. That's why algae can sometimes cannot be avoidable. Also, hot if you are working dealing with hot crude surfaces, also here cooking can occur. But what is the solution for them? Firstly, prevention always works out cheaper than mitigation issue. That's why using chemical injection beforehand, like for example, if you have calcium carbonate scale, you assume that you could have some carbonate scale. You could inject some chemical based on its dose in order to prevent it. But if prevention is like is not achievable, then we have to suggest some like prevent mitigative actions. For example, it can be mechanical cleaning by jetting hydroblasting. Like it means like jetting water by high pressure. Also cleaning, chemical cleanings, like based on again it's a chemical dosing. It can clean the already like deposition of unwanted materials. So until this part, we covered like most of important topics about heat exchanger. If you have any question, you can raise right now. If you don't have question, we will move to case study. I can see chat actually. Okay, I can't see right now any question. So I'm moving to case study. Okay. Like think firstly about what we have covered today and like look our case study within 5 minutes, and then we will move to solution like case study solution together. So here you can see the scenario. In the scenario, it's said that the overheat condenser is an air-cooled heat exchanger with 4 fan units, and it's peak summertime, and column starts making off-spec product. You know what is off-spec product? I will ask from Sarah. Sarah, what's off-spec product?
It's an extra product that we don't need, maybe.
No. What do you mean extra product?
Like the one that isn't supposed to be in the system.
Okay, undesired product, you mean?
Yes.
Yeah, it's actually undesired product, but why it's called off spec? I just wanted to hear who raised hand. Since Elvin, yes.
It's product that doesn't meet specifications. For example, temperature or amount of şey
Aha.
işkenceciler mesela o söylemiş.
Yes, exactly. Thank you, Elvin. Yes, exactly. If you like off-spec means that you have some specification from like vendor that, for example, like my oil has has to be sulfate free or has limited, for example, 2 ppm sulfate, or like it has like the color should be like this, density should be like this, temperature should be in operating range, pressure, like there is some variables that that is for your product specification. If they are out of the range, it's called off-spec product. If your product is off-spec, it creates a little bit challenge for you because you can't sell it if it's off-spec, or if it's off-spec, like you will sell it like with like undesired product price, for example. Mostly they don't like, they can't sell it because in laboratory it's checked, and if it's off spec, they return to the process. It creates additional problem for site, because you need either use it as makeup to your process, or you need to just accumulate it in one tank and then purify it with additional units or additional equipment. So basically, it means that the column started producing off-spec product. It means that out of range, out of operational range. And operators observed that like your temperature, here is 12 degree above normal temperature. Reflux drum level is dropping. You know what is the reflux drum? In distillation column, we have condenser here. In condenser, we cool down the liquid. After condensing it down with the help of reflux drum, some of them is going to the distillation column, and some of them is removed from the system. And it means that the reflux drum liquid level dropping. It's also insufficient, means that insufficient condensate returning, benzene product failing purity specification, and toluene content is too high. You have 4 fin fan units, 1 fin fan motor trip, alarm acknowledged but not investigated for 3 days, and never followed up. Then, and one of them was running, but it has some damage in the blade. Also, it's 48 degree, like the ambient temperature is 48 degree. The operators concluded that the feed composition must be changed, and we need increased reboiler duty, which made things even worse. And you have 3 questions. The first one is to just analyze what's actual root cause and what do you check first. And the second question is, why did increasing reboiler duty even make things worse? And the 3, what do you do right now to fix it in terms of short term and in long term? Yeah, that's all about the case study. Take your 5 minutes, think about the air cooler, and just write your answer to chat. We will read it, and then we will go to solution of the case study. Answer, and yes, your answer like almost were correct. Let me like say the answers and the problem, about the problem solution to you. The first question is, what is the root cause? I'm sure that like there is no need again to read the problem statement. Like we directly move to the solution. What is the root cause? Firstly, like someone walked out the air cooler and found out that one fan motor, just let me use my pen, one fan motor completely failed, like completely dead mean. like not repaired, just sitting there failed for 3 days. Like no investigation occurred. Like they removed it from the system completely. But a second fan also like used with damaged blade. It means that your airflow already decreased. Your airflow severely decreased. So you just got 2 out of 4 fans actually working for 48-degree ambient temperature. Like the temperature is already high, and like out of 4, you just have 2 like normally working fan in plant in industry, like, and the condenser, it means that like condenser overwhelms, and that's why first you need to check in the field that are all fans working, running, or is there any problem in your fans, like as it caused the increase of temperature, also like the other problems like off-spec, like producing off-spec material and so on, and also check motor status and the blade condition. As you see, one of it, although it works, but it worked with damaged blades and also airflow, that's why it decreased. And the lesson here that before you touch a single variable process, go walk to the field or go to the control room. Look at like your equipment with your own eyes, like with parameters. Are those fans actually spinning? Does your air flow feels normal? Also, this was like discoverable in just 10 minutes. But it was missed in 3 days. Like, and someone clicked on alarm acknowledgement and moved on. There is no solution for this alarm or no locked problem for this. That's the first root cause why this issue happened. It's simple. And the second question is, why did increasing reboiler duty making things worse? First of all, the reboiler, as you know, generating vapor. That vapor has to be condensed at the top. As I drew previously, you have like distillation column. At the top, you have condenser. At the bottom, you have reboiler. Yes, the reboiler is generating vapor. As it's known, the vapor has to be condensed at the top with the help of condenser. The condenser was already overwhelmed because 2 out of 4 is not working properly. Like sending more vapor, like increasing reboiler duty means that you send more vapor to your condenser. It means that more uncondensed vapor will accumulate in your condenser, and here pressure will go up. Like your pressure climb up. Also temperature profile will shift, and at the end it will cause separation efficiency decrease. Separation will not be efficient. That's why your like benzene product failing period specification, so toluene content will be high because your separation efficiency will decrease. Also, the problem was on the removal side. Like you never fix a removal problem by adding more input. If you add a little a little bit more reboiler duty, it means that you add like more input. But we need to just removal side. We need like to decrease reboiler duty rather than increasing reboiler duty. And coming to like long-term and short-term, immediate and long-term actions. First immediate action, as you know, as you said, that like reducing reboiler duty instead of increasing, because we need to get stabilized pressure under our control, and then replace and or repair failed motors. You have 4 motors, but all 4 fans should be back working state within 6 hours. Each of them should be in 6 hours. And it's the column will turn to on spec within 1 shift. It means that you have 4 fin fan. One of them is already is not working. One of them is not working properly. We need to replace both of them in order to to turn the product on spec again. But coming to long term, like fin fan motor also need mandatory field check. within each in 1 hour. So and also the second one here, as it mentioned that alarm, if I'm not mistaken, yeah, one film fan motor trip alarm acknowledge but not investigate. If alarm occur, it means that after alarm cannot be closed without the action. Yes, and it's an additional summer operating time. It means that you need to reduce your feed at least 10% when your ambient temperature exceeds 45 degrees. It's like rule of thumb, because in summer the temperature is already high. It adds a little bit more temperature to your system, and if you reduce your feed, it means that the condenser like will not be overwhelmed and will work properly rather than normal condition. Also, you need spare additional motor goes into this critical spare, because as you know, it's working with like benzene and toluene, and it's a little bit dangerous product. You need additional spare motor if one of them is not working, or just you see here we got alarm from one of them. It tripped. That's why we need to replace it like immediately. These are the solution for this case study. Do you have any question for this case study? Okay, as I understood, there is no question. This is wrap up for workshop 2 from my side. Now you will like answer the quiz questions. Thank you all